Hello, is it visible? The screen is visible.
Yes, sir.
Yes, sir.
So yesterday we were discussing this, and yesterday we are here. Sorry, actually there was a net issue, connectivity. Ka? Last 3 4 days it is going on. Pareshan. हो गए. So this we were here that EDM working principle. So the limitation is that both the tool and work material has to be conductor. Then kerosene or deionized water is used as the dielectric medium. This is important. Huh? Either a kerosene or deionized water. You will come to know why. The voltage which is applied or supplied voltage is 50 to 450 volt between the tool and the workpiece. Generally, the tool is negative and the workpiece is positive. That is, workpiece is anode and tool is cathode. So the electrons which are coming out of the tool carrying negative charge get attracted toward the workpiece, and the electrons are bombarded toward the workpiece. So the erosion takes place. This emission of electrons is called as the cold emission. Cold emissions. And remember, it is the velocity which causes the erosion. It is the velocity and not the mass of the electron. It is the velocity of the electron which causes the erosion. And depending upon the polarity, you can erode. Erosion will happen at both the places, at the electrode as well as at the workpiece. So it depends upon the polarity and where you want more erosion to occur. So obviously we want more erosion to occur at the workpiece. So that is connected at positive. So this much explanation is not required. So you can just write in short that electrode is connected to the negative, workpiece is connected to the positive. Then electrons are directed towards the workpiece and the erosion occurs. So this 5 6 lines is enough. 5 6 lines is enough. Whatever is underlined that you can remember. That is the kinetic energy of the electrons and the ions hmm, on impact with the surface of the job and the tool respectively converted into thermal energy, and that causes the erosion. And the temperature is around 10,000 degrees Celsius. So the erosion is also taking because of the heat, and that's why you have to keep on lifting the electrode, and that's why that servo plays very important role. So this is a tank. You have a tank. This is a very simple sketch which you can draw it very easily. This is your workpiece tank. You have dielectric here, and the workpiece which is connected to the positive, that is anode, tool connected to the negative, and this is what the spark is. And remember, the spark will not only come from the bottom, but the spark will come from all the sides, and the erosion will occur everywhere. That is not only at the bottom, but from the sides also, from the four sides also. So this is what is your on pulse, and this is your off. This is on, and this is off. Remember, you cannot have voltage building up instantaneously. So this is something wrong. So you should have a slight taper, because it takes some time, to build a current, whatever milliseconds or microseconds it may be. hmm, It will take small amount of time to reach to its higher value. So this is your on time, this is your off time, this is your on time, this is your off time. So the graph is voltage and current against the time. On the x-axis, there is time here, which is not shown, but I hope you know this diagram is important. I'll zoom it. Yeah. So try to understand this diagram. So I hope you have understood this diagram. So you have a fixture on which workpiece is fitted, in which the cavity is to be spark, and correspondingly you have electrode, and electrode is mounted in a tool holder. If you notice, look at the flow of the dielectric. This dielectric is nothing but coolant. It is nothing but the coolant, like our conventional machining. Now the dielectric channel is in the center of the electrode. That is this. Since the dielectric is kerosene or demineralized water, it is expensive and it is always recycled. So the dielectric is recirculated with the help of a pump, and this filter will definitely remove the debris, and the pure dielectric flows. It passes to the center of the electrode and it comes out from here over here. And the entire workpiece assembly is kept or submerged in a tank. So this is a tank from which your dielectric is collected, and it is dielectric is collected from the bottom and it is recirculated. So if you zoom this portion, and this is a DC pulse generator which has rectification and amplification circuit. This is servo control feed which keeps moving your electrode up and down. Now if you zoom here, if you look here, then you can see that there is a movement of electrons and the ions. So since this holder is negative and workpiece is positive, again and again I am telling that electrons will move toward the workpiece carrying negative charge, and the ions, which are carrying the positive charge from the workpiece will move towards the electrode. And since the electrons has very high speed, that is almost 3 into 10 raised to 8, the more erosion will occur at workpiece and less erosion will occur at electrode. And this is what we want. You can connect it ulta also, like workpiece can be here in place of electrode and electrode can be here. It depends upon if the size and configuration of the workpiece. Like if the workpiece is not heavy, then you can mount it here. But if the workpiece is heavy, then obviously workpiece has to be mounted on a table, which is stationary. Because heavy workpieces, if you want to mount here, then servo control of that heavy workpieces will be very difficult or challenging. So this portion is electrode and this portion is workpiece. So if you wish, you can draw this diagram. Hmm. Same thing, that electrons which are carrying negative charge, uh, they are attracted to the workpieces, and positive ions moves towards the tool. So, but you see that you show the wear on the electrode as well as on the workpiece, and that too how you have to show that more wear is happening on the workpiece and the less wear, that is this, is happening on the tool. So that care you have to show. Then there are different circuits, which are studied in physics, engineering physics as well as in 12th standard physics. That RC circuit is most common. RC is nothing but resistance capacitive circuit. Then you have LC circuit, that is LCL for London, that is inductance and capacitance circuit. Then you have RLC, that is resistance, capacitor, and inductor. Mostly RC circuit is commonly used. Then there are some terms like open circuit voltage, then short circuit voltage, then amplitude, then maximum duration of discharge, which you'll come to know from the diagram. Of course, if you wish, you can remember, otherwise, it is not required. But one or two terms you can definitely explain. Like open circuit voltage is the voltage between the electrodes and the workpiece, electrode and workpiece, or you can say between electrodes, because now workpiece is also called the electrode when electric is not broken. So the circuit is open. Hmm. It can be identified as a steady state voltage. And when it goes down, that is some kind of a shorting occurs, and then electron dielectric breaks and the electron jumps. So this is what is your RC circuit is. So you take uh, capacitive circuit, so it continuously charges and discharges. So this is what is your charging time, and then this is your discharging time. Again charging time, discharging time, and one charging and discharging makes one cycle. So this graph is again voltage against time. So this is showing variation of voltage with the time using RC circuit, that is resistance capacitor. This you can draw in the examination. So this is on time, this is off time. So your DC pulse generator or your power circuit in any EDM machines has facility to change this on time and off time. And then that depends upon what material removal rate you want and what finish you want. For example, first you understand what is on time and off time. On time means your sparking will be on, your current will be on, so your material removal will be on. That is, sparking is taking place, material erosion is taking place. Electrode is kissing the workpiece. And off time means there is no current which is flowing to the electrode, no sparking taking place, no material erosion taking place. So the electrode is in the up condition. On time, electrode is in the down condition and it is almost touching the workpiece. Almost touching. I'm using the word almost touching. It never touches the workpiece. Touches the workpiece means shorting. There is very small gap, of 5 microns between the electrode and workpiece, which is just enough for the electrons and ions to jump across and for the erosion to happen. So that is what is your on time. Now you can play with this on time and off time. Like suppose if you want more material removal rate, obviously you are going to keep on time more so that erosion will occur more. But then you have to take care that with this small gap, we are talking about gap of 5 micron between electrode and the workpiece, the debris will uh, move easily, flushes easily. Otherwise, what will happen? The gap is very small, the debris or the chips are unable to move out. So your electrode will keep on cutting the debris instead of cutting the workpiece. Initially, in the beginning, it will cut the workpiece, so chips will be generated. Now, chips, if your flushing is good, then chips will be moved away. But if the flushing is not good, the chips get trapped between the electrode and workpiece. And then now, subsequently, your electrode keeps on machining your chips or debris. And this is what is called the secondary cutting, which is bad. So you have to have a trade-off or compromise, between on time and off time. Obviously, if you keep off time more, this. In this case, on time and off time is same, but if you keep off time more, then what will happen? Yes, your debris will be flushed away easily, but during the off time, as I said, that machining is not happening, no erosion is happening. So obviously, your material removal rate will be slow. Your machining time will increase if you are keeping off time more. And all this on time and off time, you can adjust. Hmm? You can adjust. So most of the EDMs nowadays they are CNC control. So these parameters, can be set, and this is called as the machining condition. So machining conditions are described by four digits. For example, say 10. Uh, I will not give 110 binary. Like say 21 2132 2133. So 2134, like that there are different machining conditions. So if you talk about 2132, that is you have to just call the machining condition, you have to first save. So in the machining condition 2132, you have set a particular current, particular voltage, particular average current, particular peak current, particular on time and particular off time. Like that there are different machining condition you can save depending upon your workpiece material removal date desired, and your electrode material also. And then you can call upon that machining condition. It is exactly same as what machining you are doing in our normal machining. Hmm. That is, if it is high speed tool, then we take 25 meters per minute. If we carbide, we take 75, and so on. So something similar to that. So you have on time year, off time year. One on time plus off time makes one cycle. The graph is of current against time. Okay. Again, you when you draw, you just show a slide paper. Just give a slide paper here, because it is not possible when that when t is equal to 0, the current is 0, and at the same time when t is equal to 0, the current is 10 ampere or whatever it is. It will take some time. The peak current is nothing but the maximum current, and average current is the uh, mean current over a cycle. So this all can be set, uh, and it can be programmed in a DC pulse generator, and that's why that DC pulse generator is important. These are the machining conditions. That is, you are adjusting your current, you are adjusting your voltage, then on time and off time. Besides, you can also adjust your servo servo mechanism. That is, movement of the electron. You can make it fast up and down, fast up and down, up down, up down, up down, up down. You can move it slowly down, you can move it slowly up also. So all this plus the stroke length of the electrode, all these adjustments also can be done through the servo, and can be programmed also. Remember, the CNC program on EDM or wire EDM will not be asked, only theory portion will be covered. Now electron material plays very important role in EDM machining. Basically, there are two types of electron material which is used commonly. One is copper, or more technically, it is called as the electrolytic copper, which is available in virgin condition in USA mines. And another is your graphite. And then there are many more electrodes material like carbide, cemented carbide, and so on, silvers. But if you talk about cost and availability, then copper and graphite is most commonly used. Again, in there, graphite, that is carbon basically. So graphite is used when material removal rate required is more. And as I have been telling, if the material MRR is more, then you have to compromise finish, surface finish. So if you want a good surface finish, then you have to go for copper. So we, play around, engineers. That is, if you want to do some cavity machining, EDM machining, then first in the soft condition, you do it on the milling machine, CNC milling. So you just leave, 1 millimeter stock all around, mill it out, which is very fast in soft condition, in virgin condition of the workpiece. Then you send it for the heat treatment. Okay, so in heat treatment, the material gets harder. You receive it. Then you use a graphite electrode to do the roughing and semi-finishing. So you just leave a stop of 0.1 or 0.2, that is from 1 mm to 0.2 for the finishing, and then you use the finishing electrode made out of copper. So this is how engineer does this work. So what are the characteristics? Again, important from examination point. Describe the characteristics. Short note. Describe the characteristics of the electrode material. Obviously, it should have high electrical conductivity, high thermal conductivity, because you are seeing that the temperatures involved are in the range of 10,000 degrees Celsius. So it should have good thermal conductivity, good electrical conductivity. The density should be good, should not be porous, should withstand the temperature. The electrode material should withstand the temperature. ऐसा नहीं होना मांगता है कि instead of buckets, the electrode itself will melt. And so obviously the electrode the melting point should be more, should have high melting point. Electrode has to be machined as per the shape of the cavity to be sunk. That is as per the shape which you want in workpiece. So the electrode should not be hard. It should be easily manufacturable or it should be easily machinable. And on top of this, the cost should be good. I mean, it should not be very expensive. These are some electrodes material, that is graphite, electrolytic oxygen, free from copper, beryllium copper having 99% copper plus 0.5% tellurium. You can use electrode purely made out of brass, but the graphite is commonly used for roughing. That is when the turnover rate is high. Cost wise also it is economical, and followed by copper. Graphite we are scared to use for the finishing because graphite is brittle, as we all are aware. Hmm. And that's why we use copper for finishing. Also, the wear rate of the graphite is more as compared to copper. So, hmm, copper can be used very effectively. Many shop floors or many EDM machinists use copper for roughing as well as finishing. Of course, different electrodes, not the same electrode. A good EDM machining philosophy includes three electrodes. That is one for roughing, then second for semi-finishing, and third for the finishing. Again, the machine, the EDM machine, it has a tool magazine like our CNC milling machine. Remember, so in which you can mount the electrodes, and it's exactly like CNC milling machine tool magazine. Like if the work of roughing electrode is done, then tool change will happen. Semi-finished electrode can be called. Then again, tool change will happen and finishing electrode can be called. So this is three electrodes. Similarly, you can have electrodes for different workpieces. Generally, on CNC machine, the tool magazine is the pockets or the provision of the tool is not as high as CNC milling, where we have seen that we have 60 tools, 80 tools, 120 tools, and 180 tools. Normally, CNC machines they have maximum 20, and in general, 10 pockets are sufficient. Why? Because as compared to milling, CNC milling, we go for tool magazine because the cycle time is very short and the tool changes very often or frequent. So that is not the case in EDM. Understand? In EDM, it's a slow process. So if you mount one electrode, probably it goes for half an hour to 1 hour. So that's why It can be done manually. So investment in tool magazine is not feasible unless you run the machine unmanned for one shift, for sometimes two shifts, and sometimes three shifts also. So there, yes, you can fix up all the electrodes, design electrodes, and leave the machine unmanned. Of course, you have to take care of safety issues because you are playing. We are talking about 10,000 degrees Celsius temperature. So they should not, the fire should not take place. So you should have, sensors to detect the fire, to detect the smoke, mm, to enable the fire extinguishers, smoke detectors, and to pause the machining and again to resume the machining. So this all adaptive controls or something called as the intelligence or smart machining mm, should be there if you want to leave the machine unmanned. And yes, people are working unmanned because in EDM, what happens? You cannot afford to keep the operator, one operator for one machine, because once he puts the electrode, uh, then what? It keeps on sinking, isn't it? Going on down, down, down. So what is going to do for the 2 hours, isn't it? So one operator is supposed to take care of 5 6 machines. That is a common practice in EDM shops. His role is only at the time of setting up the new electrode, because electrode you have to set up, you have to true the electrode in all the three planes. If it is a rectangular, even if it is round, also you have to set it in all the three planes. That is in X, Y, and in Z direction. Also you have to set it, and then you have to sync it. So these are some properties like copper has good wear. Good wear means the wear is less, and this is what we want. That electrode should wear less and better conductivity. Then it can give, commonly it is used for giving better finishes in the range of zero point 0.5 micron, that is half a micron, that is 0.0005 millimeter. Electrode movement is very important in EDM. uh, That is, electrode movement means that servo movement, that is moving up and down. It has to move up, it has to move down. That movement and that positioning, that braking, that is applying the brake, releasing the brake, and movement should happen, precisely. So servo mechanism should be very, very powerful and precise. The world best EDM machine is Charmy from the Swiss. Charming face. So actually it is charmless, but it is called as a Charmy Swiss machine. That is the world best EDM machine, as well as the most expensive also. You have other machines like Technocore in Indians also in India, and Sparkonix, and even Micromatic also makes EDM machines. Most of the people who manufacture CNC milling, uh, they are capable enough to manufacture EDM machines also. But again, the technology varies. That is, what do you want? Hmm? If you want good MRR, then go for Sparkonix. It's a booth. Tap 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 tap. If you want good surface finish, go for Charming. As I said, that workpiece where again this is important from your examination point of view, that describe the 3 to 4 marks or sometimes 2 marks also. Describe the various types of so depending upon the marks you have to describe. So describe the various kinds of the electrode wear. So see, this is what the electrode wears has happened, and basically there are 3 kinds of wear ratio. One is called the corner wear ratio, another is your side wear ratio, and third is your end wear ratio. So this, and there are mathematical models also, that how to define corner, side, and end wear ratio. So the diagram is clear here. You can have a look. Let's try to understand. So I hope you understood this. So our task is to reduce this wear, that is, in ideal condition we should not have any wear ratios in electrode, that is it should be zero. Hmm? In ideal condition tool electrode wear should be zero, and workpiece wear should be infinite. So as I said, electrode wear are expressed as end wear, side wear, corner wear, and volume wear. So generally we express in volume wear, so we understand how much is the electrode wear. and accordingly the engineer an engineer takes the decision. There are some machines, so they market themselves as nowhere EDM. Nowhere EDM means what? That electrode to workpiece ratio is 1% or less. See, nowhere EDM doesn't mean that where is zero. So where will always happen. Remember, where will always happen, but it is 1% or less. So you have different technology for that machine. Accordingly, you have to go for the circuits so that there is very less wear at the electrode. Here is a mathematical model to calculate the wear rate of the electrode tool material and wear ratio. Just if anybody is interested. So wear rate of the tool is given by this. So as you can see here, wear rate is a function of I and T. So it's a function of current and it's a function of melting point of the tool electrode, that is TT. So this is wear rate of the electrode tool material and this is your wear ratio. So more the current, the more is the wear of the electrode. Again, important. See, there is not much to ask on EDM, so that's why we have to study EDM properly. Like explain the role of dielectric, explain the advantages of dielectric. You know, such type of questions are asked frequently. Hmm. And why it is important? Because EDM is a popular process. So every 5 minutes you walk, inside you will find EDM. So the function of the dielectric is, to provide and most important is to provide an oxygen-free machining environment. The most commonly used dielectric is kerosene and deionized water. See, remember, it's a deionized water. So the tap water cannot be used because it ionizes too early. So what are the important functions of the dielectric in EDM? It insulates the gap between the tool and the work. It cools the electrode as well as workpiece, and it flushes away the metal particles, that is debris. In order to have economical machining, we are filtering and recirculating the dielectric. Another requirements is that it should have adequate viscosity, that it should flow properly, should have high flash point, then good oxidation stability, It should be orderless because some cheap dielectrics uh, will not allow operator to work. It is so, I mean, the order is not that. You might have noticed, some coolants they have, nowadays, the sandwich, etc. They supply the coolant with, good fragrance, like perfume like smell. So the operator and whoever is there around, uh, they also enjoy. So that is a good ergonomics. And of course, the dielectric should have a good electrical discharge efficiency. Now, flushing is very important in EDM. Flushing. The purpose of flushing is that what is flushing? That it is a process of introducing clean, filtered dielectric fluid into the spark gap. Spark gap. See, what is spark gap? Electrode is never touching the workpiece. There is a small gap, between the electrode and the workpiece. That gap is called as the spark gap. So this will continue in the next class, flushing. So you can join your another class, or if you have any queries, we can take it. Thank you.